So we are back for chapter 9. What's chapter 9? How about chapter 9, lesson 2, line of best fit? I don't know if I should delete that and start over or just keep recording. I think I'm just going to keep it. And well, we are back for chapter 9, lesson 2, lines of best fit. So problem number 1 here is sketching the line of best fit. This is a really easy section here, you guys. The data points on the scatter plot below show the number of hours worked and the amount of money spent on entertainment last week by 24 students. Draw the line of best fit for these data points. It does not have to be the exact line of best fit, just draw your best approximation. So a line of best fit is just simply a straight line that kind of mirrors the data points that you have. So I'm going to switch to a line right here. Okay, now, so I would kind of want to graph a line through this. So if I did a line right here, that's not going through those data points. It's too high. This line here is too low. That's not going through the data points. So what we really want to do is we want to draw a line so that the data points are about half of them are above our line and about half of them are below the line. So if I start over here kind of by the 5, and if I work my way up, that looks like about half the lines are above, or half of the X's are above it, and about half of the X's below it. So that's a pretty good line of best fit, okay? There's one thing that I want you guys to be aware of, is that when you guys are drawing a line of best fit, sometimes it makes it a little bit easier if your line of best fit goes through a point down here like the 5 over 0 and up 5, because we might have to write an equation, and if it goes through an exact point like that, it makes it a little bit easier. Maybe up here we can go ahead and say that that point is over 20 and up 45. So if we had to write the equation of a line, we could use those 2 points, this one here and this one here, and we would have 2 points. Then we can go ahead and figure out the slope, and then we can write the equation of a line. Okay, is that necessary on this problem? Nope. So we are done with problem number 1. All right, looking at problem number 2, the scatter plot shows the time spent texting and the time spent exercising by each of 25 students last week. Also shown as the line of best fit for the data, fill in the blanks. Hey, I want to go back to the last problem real quickly here, you guys. And I want you to know that when we sketch the line of best fit, that line could have a positive correlation or a positive slope. It could also have a negative correlation, like a negative slope, this one here. You just want to make sure that your line is going through where about half of the X's are above it, or the data points, and about half the data points are below it. Okay? All right, so let's go ahead and take care of this one right here. We've got a few questions, so let's kind of take a look at this here. I'm going to switch away from the line tool and go to the freehand tool. So let's look at the data on the x-axis, and that's the time spent texting in hours. And let's also go ahead and look at the y-axis, and that's the time spent exercising. And just kind of think about it for a second. The more you are on a TV or on a phone or any other device, the less time that you have to be outside, and the less time that you have to exercise. So this kind of makes sense to me, that if I look at this, I can see that if I spend an hour texting, I might be able to exercise for 8 hours. If I am spending 4 hours texting, it looks like that's going to kind of go up to right about here, and we'll follow that over here. So I might only have 6 hours of exercise. So it makes sense to me. So let's go ahead and answer the questions here. So part A, for these 25 students, and that's right down here. So for these 25 students, as the time spent texting increases, so we are increasing the amount of time that we are texting. Exercising tends to, and so as this number increases, you can see that everything over here, it decreases. So I'm assuming that right underneath that arrow, we can say that it would be decreasing. How's this lovely text? Can you guys read that okay? All right, so let's go ahead and look at part B. So for these 25 students, there is a blank correlation between time spent texting. So let's look at this here. We can see that this would be a negative slope. So that there is going to be a negative correlation, probably negative linear, right? Negative linear. And let's go ahead and go down to C, and part C says, using the line of best fit, we would predict that a student texting for 6 hours would exercise for, so let's kind of come over here and let's go to the 6. So here's the 6. Let's go ahead and follow that all the way up until we hit the line of best fit. So I'm going to follow that up there, and I'm going to hit the line of best fit. Let me change the color here. Maybe I'll change the color. I guess I won't. Okay, so in any case, when I follow this line up right here, you guys, it looks like that's going to come right over here. So that to me looks like it's about 4.5 hours. So down here we would say about 4.5 hours. Okay, that's it. Easy section. And that's actually, we're not done with the section, are we? We've got 2 more problems to do. So let's go ahead and take care of those. Okay, next one here, you guys. Predictions from the line of best fit. The scatter plot shows the number of hours worked, X. So X is the number of hours worked. That's what that means. And the amount of money spent on entertainment, Y. So Y is the amount of money spent on entertainment by 23 students. So if we go ahead and look at the X and the Y axis, down here on the X-axis, this is going to be the number of hours worked. The Y-axis is going to be the amount of money that's spent. And if I look at my line of best fit, I can follow this up here from, 2 hours worked looks like 15. So if they work for 2 hours, they're going to spend about $15 on entertainment. So that's how we're going to read that. Let's go ahead and look at the questions here. So we've got question A says, what is the predicted amount of money spent on entertainment for a student that doesn't work any hours? So let's come down here on the X-axis and let's go to 0 hours. And let's go ahead and follow that up. So now if we follow it up here, I can see that this line is going to come down here and maybe somewhere around 11. But one of the nice things that they do for us in this particular problem is that they give us this equation. All right, so we're going to use that equation. So they are telling us that this student doesn't work at all. So on the X-axis, we're going to put in a 0 for the X, right? So then the output is going to be Y. So the amount of money spent is Y, and that's going to be $1.83 times 0. So that's going to be 183 times 0 is 0. Plus $11.34. Okay, so this is going to be $11.34. Okay, and remember this 11.34 in the equation y equals mx plus b, that is the y-intercept, and that's kind of what we figured out, right? And the slope of this line is 1.83. Okay, let's go ahead and take a look at problem number 2. Now we're going to use the exact same equation. This time here, what they want me to do is they want me to predict how much for 12 hours. So let's just go ahead and say y is going to be equal to 1.83 times 12 plus 1134. Okay, so let's do 1.83 times 12, and that's going to give me 2196. So we've got 2196, and then we're going to go ahead and add in 1134 to that. And what we'll end up with then is 33.3. Let's go ahead and kind of cross-check that. So we said 12 hours, so let's take this 12 hours right over here, and let's follow this 12 hours up to that point there, and then we'll come over. It looks like it's just below that, right around there. And you'll notice that that's between the 30 and the 35. So our answer of 33.3 or $33.30 is right on the money. Okay, we've got part C here, so let's go ahead and address that. So part C, for an increase of 1 hour in time worked, what is the predicted increase in the amount of money spent on entertainment? So that problem there, you guys, is a fancy way of them asking for the slope, right? Remember the rate of change, and we've got 1 unit here. Whoops, there we go. So in 1 hour, they want to know how much is this rising for every 1 hour that we go over. That's going over 2, this is going over 2. So we could pick a couple of points and find the slope, but hopefully you guys remember that that's the slope of the line right there. So for every hour, it's changing by $1.83. Okay, whoops. There we go. We've got one more to go here, you guys. All right, the last one of the section, you guys, approximating the equation of a line of best fit and making predictions. The scatter plot shows the time spent watching TV, X, so TV is on the X-axis, and the time spent doing the homework is on the Y-axis, by each of 24 students. Okay, so write in an approximate equation of the line of best fit for the data. It doesn't have to be the exact line of best fit. So the first thing we have to do is go ahead and get ourselves a line of best fit. So I want about half of my dots to go above this, and I want about half of my dots to go below this. So I'm going to kind of, look at it. Maybe we're kind of doing something. I don't know. How does that look there, you guys? So to me, that looks fine, right? It doesn't have to be perfect. We're just approximating right here. So I'm going to go ahead and go with that. So that's part A. We've got our line of best fit. Oh, actually, we have to go ahead and write an equation for that. So I'm going to identify a couple of things here, you guys. We need to find 2 points that are on our line. So let's see, let's go ahead and use 28, and this looks like this would be a 6, right? So if I follow this over to the side, we'd have a 6. So I'm going to have a 28 and a 6. That's going to be one of my points. So let's do, whoops, the 2 is always hard. 28 and 6. That's going to be 1 point. And why don't we go ahead and pick a different point? I don't know, maybe I'm going to come over here to the 4, and it looks like this might be a 23. So if I go over 4 and up 23, so then that's going to be my other point. So I'll just say 4 and 23. So what we need to do is we need to find the slope of that line. So if we have 2 points, we can go ahead and find the slope. So y2 minus y1, if you guys recall that. Let me change colors here. So let's go ahead and do y2 minus y1 over x2 minus x1. So if I'm going to do that, this is going to be y2, this is going to be y1. So it's going to be 6 minus 23, and x2 is going to be 28, and x1 is going to be 4. So I'll have 28 minus 4. So that's going to give me a negative 17 over 24. And if I simplify that, that's going to give me 0.708. So let's round that to a negative. I'm going to put it down here. So we're going to say that our slope then is, we'll just do negative 17 divided by 24, and then we'll just round that, and we'll say that's about 0.71. Okay, so I'm not too sure where everything just went, you guys. So let's, we don't have to add in a whole lot of stuff. So we just figured out that our slope then was a negative, and we said it was 0.71. Okay, do you guys recall point slope? Y minus y1 is equal to m times the quantity x minus x1. So we're going to use that, and we're going to finish up the equation of a line. Now you guys remember that we had a couple of points here. We had 4 and 26. That was one of the points that I could use. I think I'm going to use that. 4 and 26. They're both even numbers. It's going to be easy to work with. So let's fill in the blanks. So we'll say y minus y1, which is going to be 26, is equal to now our slope, which is negative 0.71, and x minus x1, and we said that x1 is 4. So we'll go ahead and do that right there. So over 4 and up 26. Is that right? Did we go up 26? No, we went up 23, didn't we, you guys? So let's make this a 23. And then we're going to change this to a 23 over here. Okay, so let's bring this part down here. Y minus 23. And they're both not even, they're not even numbers anymore, but that doesn't matter, you guys. So let's go ahead and do 0.71 times x, because we're distributing here. So that's going to give me 0.71x. And then I'm also going to have to do 0.71 times the 4 right there. So you can see that we've got a negative and a negative. So that's going to give me a positive. So that's a positive 2.84. Okay, we're almost done here, you guys. Now we got to go ahead and add 23 to this side. Let's go ahead and add 23 to this side here. Line up your decimals. You can put in a couple of zeros if you want to, but you don't need to. So on the left side here, we have y is equal to negative 0.71x. And we've got 2.84 plus 23, so that's going to give me a positive 25.84. That's my equation. A couple of things I want you guys to look at real quickly here is This is the y-intercept, 25.84, and it looks like our line, if our line was still there, if you guys recall, it was kind of down here and then it came up similar to that. So that looks like it's right on the money, right around the 25, so 25.84. And again, that's the initial value, so that's an equation. Let's go ahead and use our equation to predict the same time spent doing homework for a student who spends 15 hours watching TV. So the only thing you need to do now is you just need to put in a 15 right there. Okay, now let's get ourselves an estimate. So 15 is probably going to be right around here. And if we were to follow that 15 up, it looks like it would be someplace in this general area, so someplace right around there. Let's actually do the math, okay? So we're going to put in a 15 right here. So I've got my handy dandy calculator right here, so we're going to go ahead and do 0.71, or a negative 0.71 times 15, and that's going to give me 10.65. So we're going to have y is equal to a negative 10.65. And again, that came by multiplying these two together here. Actually, not the x, because 15 is x, so 7.71 times 15. And then we have to add in 2584. So when we add them together, you guys, we get y is equal to 15.19, and that was very close to our estimate. So it looks like we're in good shape, you guys. So that's it right there. So we have our equation. So you may be asked to write the equation of a line. That's our equation. And then if we input a 15 for x, because that's what they're telling me, x is going to be 15. What do we get for the output? And we would end up with 15.19. Okay, it takes a little bit of work, you guys, but you've done enough with writing the equation of a line that I don't think that you guys are going to have issues. But as always, if you do, make sure you guys just let me know. Okay, until next time.